Good morning students. In last video we was discussed about several examples for push down automata. That means different types of languages, how to construct push down automata for several languages. So in this video we can discuss about how to construct push down automata for the language. So which contains balanced parenthesis. So here balanced parenthesis means already well known about this one. So that means number of open parenthesis is equivalent to number of closed parenthesis, and then here first can be occur open parenthesis only. So that means either first left open parenthesis and then closed parenthesis. Otherwise two open parenthesis, one closed parenthesis, again open parenthesis and closed parenthesis in this manner. So that means here number of open parenthesis is can be greater number of closed parenthesis in order, not totally. So that means, so whenever creating the string with the parenthesis, so we consider either out of string length is either 4 or 3, either 4 or 10, 4 or 5. So in this length, number of open parenthesis must be greater number of closed parenthesis. That means either number of open parenthesis is more than number of closed parenthesis before ending the string is acceptable. So but in case number of open parenthesis is less than number of closed parenthesis is not acceptable in anywhere, either first 3 symbols or first 5 symbols or anyone. So it was not acceptable, but finally number of open parenthesis and number of closed parenthesis must be equal, just like number of A's is equivalent to number of B's. But here open parenthesis is first created and then closed parenthesis can be allowed. That is the only small variation. And here also one more example is construct PDA, which was also recognizes the balanced parenthesis or well formed parenthesis. But here parentheses are considered as normal open parenthesis and closed parenthesis, square braces and curly braces. These three types of parentheses can be allowed, but in first one we consider only open parenthesis and then closed parenthesis. In second one we consider these all are. This is the only variation. That means when read open parenthesis we perform the push operation, and when read closed parenthesis we perform the pop operation. So at the same way, when read open parenthesis of this one or this model we perform the push operation. When read closed parenthesis and then top of the stack is same model, then only we perform the pop operation. So that means input is closed parenthesis and top of the stack is open parenthesis, then perform the pop operation. Either input is squared parenthesis, square closed parenthesis, and top of the stack is square open parenthesis, then also perform the pop operation. Either input is curly braces closed and top of the stack is curly braces open, then also perform the pop operation. In case input is open and top of the stack is open, then perform the push operation. In case input is open and top of the stack is this one, then also perform the push operation in this manner. So here when we read open parenthesis, which may be any type, then perform the push operation. When we read closed parenthesis and top of the stack is must be open parenthesis, then only we perform the pop operation. So this is the process of implementing the push down automata for this type of languages. But in these two examples only the variation is in the place of this parenthesis, here we can read three types of parenthesis, normal open and square braces and curly braces. That is the only variation. For example, here open parenthesis considered as A and open closed parenthesis considered as B. Then when we read any number of A's, perform the push operation. When we read any number of B's, perform the pop operation in this manner. Here also we consider open parenthesis as A and closed parenthesis as B, and within A it contains three subcategories, that like as A1, A2, A3. So when we read A1 or A2 or A3, then perform the push operation, and closed parenthesis considered as a B1, B2, B3. Then when we read input as B1 and top of the stack is A1, then perform pop operation. When we read input as B2, top of the stack is A2, then perform the pop operation. Either input is B3 and top of the stack is A3, then only perform the pop operation. In remaining all possibilities we can perform the push operation. So this is the way of implementing the push down automata for this type of languages. So just now we discussed, when we read open parenthesis then perform the push operation, when we read closed parenthesis then perform the pop operation. So these are the IDs for this language. So from initial state, input is open parenthesis and top of the stack is z naught, then perform the push operation. Here open parenthesis will be push into the stack and go to same state, and input is q naught, sorry, current state is q naught, input is open parenthesis, top of the stack is also open parenthesis, then also perform the push operation. In case input is q naught, sorry, current state is q naught, input is closed parenthesis and top of the stack is open parenthesis, then only perform the pop operation. So both different combinations, then only perform the pop operation. And in case current input is end of the input del and top of the stack is empty, then we can say that those are balanced, those parentheses are balanced, that's why going to accept. So now we consider some input string and perform the simulation. And before that, push down automata for this language is this one. So from initial state, when we read open parenthesis as input, top of the stack is z naught, then perform push operation. So open parenthesis as input, top of the stack is open parenthesis, then perform push operation. In case input is closed parenthesis, top of the stack is open parenthesis, then perform the pop operation. And in case input is end of the input, that means a del, and top of the stack is z naught, then going to accept our final state. So now we consider some string, that is open parenthesis, closed, closed, and open, close, open, close. So here check. So open parenthesis 1, 2. So first open parenthesis closed, and second parenthesis closed. So till now balanced, parentheses are balanced. Next new parenthesis open, again open. So till now two parentheses are open and one parenthesis will be closed. So that's why remaining is one parenthesis open, and here one more parenthesis open, that means till now two parentheses are open, and here close one parenthesis, remaining is one parenthesis, so that parenthesis is also closed. So finally parentheses are balanced. So here we observe clearly in this part. So here first we create we consider two open parentheses and single closed parenthesis, after that again open parenthesis. So this type of combination is allowed. So in case first closed parenthesis again open parenthesis, this type of combination is never allowed in balanced parenthesis. Either open, close, again close, open. So this combination is also not allowed in balanced parenthesis. So that is, here number of open parentheses more up to some part of the string is allowed, but finally completion of the string both are balanced or both are equal. At the same way, number of closed parenthesis is more up to some part of the string is not allowed. So that is the only restriction to compare previous languages. So now consider simulation or tracing. So now we are starting from initial state q naught and input is open parenthesis and top of the stack is z naught. So that's why push operation. So this is the initial configuration of stack. After performing the push operation, this is the stack. So and then go to same state, that's why q naught. Next input is also open parenthesis, top of the stack is open parenthesis. So based on id2 we perform the push operation. So this is the previously configuration of stack. So now we are performing the push operation into the stack, that's why after performing push operation, so this is the stack, two open parenthesis, and going to the same state q naught. So that's why consider from q naught, next input symbol is closed parenthesis, already first two completed, remaining is closed parenthesis. So that's why closed parenthesis, and top of the stack is open parenthesis. Based on id3 we perform the pop operation. So before performing operation, this is the stack. So now we want to pop the top of the stack, so that is this can be popped from the stack. After performing the pop operation, this is the stack combination, stack configuration. So and then go to the same state q naught. So now current state is q naught and input symbol is open parenthesis, sorry, closed parenthesis, and top of the stack is open parenthesis. Based on ID3 we perform the pop operation. So that means this open parenthesis will be popped from the stack. So then after performing the stack operation, this is the stack configuration. So now we going to next state as Q0. So Q0 current input is open parenthesis and top of the stack is Z0. So based on ID1 we perform the push operation. So here initially stack is, so now stack is empty. When we perform the push operation, then open parenthesis will be pushed into the stack. And next input symbol is open parenthesis and current state is Q0 and top of the stack is open parenthesis. Based on ID2 we perform the push operation. That means here we perform the one more open parenthesis into the stack. So that's why after completion of stack it contains two open parentheses. So now next state is Q0 and input is closed parenthesis and top of the stack is open parenthesis. So based on ID3 we perform the pop operation. That means this top of the stack element will be popped from the stack. After performing stack operation, these are the details. And next going to same Q0. From Q0 next input is open and top of the stack is open parenthesis. That's why push operation based on ID2. So that means initially top of the stack is open parenthesis and now we are trying to push into stack open parenthesis. That's why this is the stack configuration after completion of stack operation. And then go to the same state Q0. So now current state is Q0, top of this input symbol is closed parenthesis and top of the stack is open parenthesis. Based on ID3 we perform the pop operation. That's why top of the stack symbol, this open parenthesis popped from the stack. Then remaining stack elements is open parenthesis and then Z0. And then go to the same state Q0. So from current state is Q0 and open current input symbol is closed parenthesis and top of the stack is open parenthesis. Based on ID3 we perform the pop operation. That means this element will be popped from the stack, then stack is empty and input is also completed. Input is also completed. That's why going to accept our final state. So therefore the string contains the parenthesis, this one, two open parenthesis, two closed parenthesis, two open parenthesis, one closed and one open and two closed parenthesis is accepted by PDA. So this is the process of constructing PDA for the balanced parenthesis or well formed parenthesis. So in case we consider parenthesis as normal and square and then flower braces, then we can write the ID for each and every combination. So Q0 comma normal parenthesis comma Z0 push, either square comma Z0 push, either curly comma Z0 push, either normal parenthesis is the input and top of the stack is open parenthesis of square, then also perform the push. Every combination is push operation. Only reverse combination, that means input is closed parenthesis and top of the stack is open parenthesis, then perform the pop operation. Input is closed parenthesis of square braces and output top of the stack is open square braces, then also perform the pop operation. At the same way input is curly braces closed and top of the stack is curly open braces, then perform the pop operation. In these three situations only we perform the pop operation. Remaining all combinations we can perform the push operation. So these are the details about how to construct push down automata for balanced parenthesis or well formed parenthesis. Thank you.